Welcome back, everyone. In this lesson and the next lesson, we want to talk a little bit about an important use that truth tables have. And that use is they can help us to test to see whether an argument is valid or not. At the same time, I want to give you an idea of what the test questions are going to look like when you take your test, and also how I would like you to fill in the tables. So let's take a look at this example here. This one says, construct a truth table for the following argument and say whether the argument is valid or invalid. And in this case, the argument says, if A then B, that's our first premise. Second premise says, not B. And the conclusion says, not A. So in this case, the little triangle dot thing means therefore. So what we're going to do here is we're going to build our truth tables the same way we've been doing. But what we're going to do this time is we're going to have a column for the premise, if A then B. We're going to have a column for the negation, not B. And we're going to have a column for the conclusion, not A. And of course, as before, we are going to have the columns for the inputs. And in this case, you're just going to have A and the letter B, because those are our inputs. So let's build the table first. In this case, using Canvas, I'm going to build the table with this little table builder. And I'm going to have, let's see, I need 2 columns for my letters, and then I need 3 columns for the premises. So in this case, that'll be 5 across. Then I know that if I have 2 letters, I'm going to have 4 rows in my table. 1, 2, 3, 4. And I'm going to add an extra row so that I have a place to put my letters. So I'll put those in right here. So I'm going to go, in this case, 5 by 5, like that. That gives me my table. And now let's see. Let's see. All right, and I'll compress this just a little, like so. And so then I'm going to put in a space for the letter A, and I'm going to put in a space for the letter B. And then what I'm going to do, I'm going to copy and paste each of the premises. So first premise, put it here. Second premise, put it in its own column, like so. And then finally the conclusion, we will put in the final column, like that. And now we've got our table set up. Now, of course, you can build tables different ways. I recommend doing it this way. And always make sure that when you're testing an argument, you know where your conclusion is. That, as we're going to see, that's very important. So we're going to plug in the values for our inputs. That's our left-hand side here, A by itself, B by itself. And we know that we're going to plug in true, true, second, and then false, false, like that. And B, we're going to go half again, because this was our half on, half off method. So true, false, true, false. Now we remember this was our input line, and everything on the right side, we're putting in the values for what happens when we add our letters or statements to a connective. When we put a connective with it, we want to find out what the truth value becomes. So in this case, we read this from left to right. So in this case, right, you can think of each of these possibilities. First possibility, second possibility, third possibility, fourth possibility. And in this case, we're just going to go left to right. So let's, in this case, take the statement, if A then B. And we know that in this case, it's true in the first column. So we'll put that in. And in the second column, we know if A is true, B is false, that possibility turns out to be false. The third column, A is false, B is true, that turns out to be true. And finally, A is false, B is false, that possibility is also true. Now, next column over, we know this is the negation of B right here. So in this case, we go back to our input row with B sitting here. And in this case, we know that the negation reverses the truth value. So in this case, the input says B is true, false, true, false. Those are going to be reversed. Not B will be false, true, false, true, like that. And finally, negation of A, this is our conclusion column. And we go back to A, and we noticed again that A had 2 true and 2 false, like that. Well, now those columns are going to be reversed. They're going to become 2 false and 2 true. Okay. Now our table is complete. The last step, we need to be able to go in and say whether the argument is valid or not. Now remember, what does it mean for an argument to be valid? So in this case, I'm going to write this in just so you can see it. We know that an argument is valid when, well, if it is impossible for the premises to be true and the conclusion to be false. And we're going to say that an argument is invalid when it is possible for the premises to be true and the conclusion to be false. Well, now we look at our table, and what we're looking for is we are looking for a case or a row in which the premises are true, both premises, and the conclusion is false. So in this case, we look at the first one. Our input was true, true, and in this case, well, actually the second premise is false, so that one doesn't count. In the second case, we had input A true, B false, and actually look at this, the first premise, if A then B, that one turns out to be false. So again, not all true premises, so we're not going to be concerned. The third possibility, well, A is false, B is true, right? And so then the third here is true, but then look at the not B, it's got a false. So again, we don't worry about it. It turns out there's only one row where we have all true premises. It turns out when we input A false, B false, the premises are both true, and then look at this, the conclusion is true. So now we ask ourselves, is it possible to have true premises and a false conclusion? And it turns out in this argument form, that's impossible. The only possibility where we have true premises is the last column, and it has a true conclusion. So this argument is, put it in here, valid. So that's a valid argument. We saw earlier when we memorized our forms that this form is called modus tollens, and I said at the time that it was valid. But now we can see something really valuable about truth tables. And when we build truth tables, we no longer have to take it on faith that an argument is valid or invalid. We simply build the table and check. And I think that's good news. Thank you for listening. I'll see you in the next video.